All right, let's take a look at the problems like what we're seeing on the sunshine worksheet as far as simplifying radicals. So let's just start with the front and something simple like the square root of 40. Okay, so what I'm looking for are hidden perfect squares. So I could either break it down completely and find pairs, or I can look for those perfect squares. Now remember, like my perfect squares would be like 2 squared, which is 4. 3 squared, which is 9, 4 squared, which is 16, 5 squared, 25, and so on. So, taking a look here, 40 is divisible by 4. So if I break up the 40 into 4 times 10, I do have a perfect square. Now 10 can be broken up, but it's only going to become 2 times 5. Right? And there's no perfect square there. So really, we don't need to break that up anymore. We can leave it because there is no perfect square. Square root of 4, we can find the square root of that and bring it out. So the square root of 4 is 2. And then we have still left inside the square root of 10. That is our answer. So we have to look for those perfect squares, pull them out. If we would have had something on the outside here, like a 3 square root of 40, then we would just multiply that 3 with that 2 to where we would end up with 6 root 10. Okay, so it depends. If there's something out front, we can't just ignore it, but we do bring stuff out and try to simplify still. Okay, so let's talk about the backside, because the backside's what's a little bit confusing, and we may not have as much class time to talk about that. So what if I have something like, let's do 2, well, no, let's do 6, no, we'll do this, 2 over the square root of 3. So this is what we call rationalizing a denominator. We cannot have a radical in the denominator. Well, so in order to get rid of it, I have to multiply it by itself, because if I take the square root of 3 times the square root of 3, that's going to be the square root of 9, and I end up with 3. So what's going to happen is I'm going to multiply here by the square root of 3. But if I just do that, then I've changed the value. So I also have to multiply the numerator by the square root of 3 as well. Because here's the thing, square root of 3 over square root of 3, this right here is equal to 1. And when we multiply something by 1, we don't change the value. So we've got this that we're working with here. And so this is going to equal, I'm going to have 2 square roots of 3. And 3, the square root of 3 times the square root of 3 would be the square root of 9. Well, I can simplify the square root of 9. So I'd have 2 square roots of 3 all over 3. And I'm double checking to make sure, can I simplify something or anything like that? And I can't. So that is my answer right here. Okay. Let's try this one. 5 over the square root of 10. So 5 over the square root of 10. So I can't have that denominator to be a radical, so I am going to multiply both of these by the square root of 10. Okay, because the square root of 10 over square root of 10 is equal to 1, so it doesn't change the value. If I just multiply, I have 5 root 10 over the square root of 100, or just 10. Now, take a look. I can simplify something. If I look at, not in the radical symbol, because the square root of 10, there's no perfect squares hiding there, but 5 over 10 could be simplified. So I can look at just this part right here and think, oh, it's like a fraction. I can simplify that. So 5 over 10 is the same thing as 1/2. So I would just have a 1 square root of 10. So I don't really need that 1. And then this would become a 2, because this would simplify down to 1/2 there. And so the square root of 10 over 2, and that would be our answer. Okay. Okay, let's look at one more example. let's do 10 over the square root of 50. All right, so we can't have that radical in the bottom. So in order to get rid of it, I'm going to multiply both numerator and denominator by the square root of 50. Okay, well, the square root of 50 times 10 is just going to be 10 root 50. And then 50 times 50, and then the square root of it would just get us back to 50. Now I need to look for simplifying, and there's a couple of different places I can simplify at this point. So if I take a look, this can be simplified as well. There, we have to check and see, is there a perfect square hidden under there? And there is, because it's the square root of 25 times 2, right? 25 times 2. And so the square root of 25 I can pull out and have a 5 there, right? So I can pull that out and I'd have a 5. So what I'd end up with is 5 root 2, because the 2 is still underneath there. But I still have this 10 here, and then I have a 50 on the bottom. So here's the thing. If I multiply what's here, the 5 times 10, that gives me 50 root 2 over 50. Well, look at that, 50 over 50, those would cancel out. And so we'd end up with just our answer after all of that to be just root 2. And that would be our answer. So we went from 10 over the square root of 50 down to just root 2 because of all the simplifying that we can do. Okay. If you're lost, come in and ask questions. This should help you with the back of Sunshine. In fact, let me do one directly from there so that if you are paying attention and doing what you need to do, you'll know that. Okay, so let's look at number 27. We've got 20 and 5 root 5. So I need to get rid of that on the bottom. And in order to do that, I'm going to multiply both by root 5. Okay, so what do I have on top? I have 20 root 5 over 5 times, and then these two put together would just be 5. So basically I'd have 25 on the bottom. So I'd have 20 root 5 all over 25. Well, if I take a look, whoopsie, that wasn't supposed to happen. That's supposed to happen. Okay, if I take a look, 20 over 25 can be simplified. It can both divisible by 5, so it would be 4 and the 5, and we still have this root 5 here. Because I just simplified the 20 over 25. So my answer would be that right there. All right, well, good luck. Keep working on it. See me if you need help.